I'm in kilometers cubed, right? So I'm going to have to go to from centimeters to kilometers. Agreed? Centimeters to kilometers. So I'm just going to write that down. I need to go from centimeters to kilometers. You need to determine what that is, because I do not believe that's on here, right? It's not on here, but it is on here. So how do you go from, when you go from centimeters to kilometers? You know what, I think maybe y'all might be having a problem with this because they're not, could you do that? Could you do meters to kilometers? Okay, what would that be?
1 kilometer.
1 kilometer is 1,000 meters. That's okay.
Centimeters to meters.
Yeah. Now let's go from centimeters to meters. There's 100 centimeters. So where are you seeing that? When you're on centi, right? Is it 100 or? You're saying 100 on this side or this side? It's 100 centimeters in 1 meter. We could do it this way. It's a lot of conversions to do, right? But that is a path to get us there. Any questions? Here we go.
Is it the only path?
It's probably not the only path. Because you could have gone straight from centimeters to kilometers. But I did that just because I think that made the most sense, I hope. All right, what do you want to start with here? Kilometer. Let's kill off our kilometer cubed. So we're going to need to use this one, right? How many of these? 3 of them. Oh my goodness. Okay. So what goes on the bottom? 1 kilometer. What goes on top? 1,000 meters. And I need to do that 3 times. Yeah, I might just add the exponents. What will that allow me to kill off? All my kilometers. Okay. Now I'm going to go and try and get out of the meters and get to centimeters. So meters to centimeters, I'm going to do what here? 1 meter where? 100 centimeters over 1 meter. 100 centimeters over 1 meter. Whoa. And 100 centimeters over 1 meter. I have to do it 3 times because, well, it's cubed, right? I can kill off the meters. And those 3 centimeters together are centimeters cubed, aren't they? And what do I know about centimeters cubed? I erased it here, but centimeters cubed, one of them is what? 1 milliliter. So 1 ml on top. We almost there? What's last? 1,000 milliliters. So that'll be on the top or bottom here. Bottom, 1,000 milliliters is 1 liter. Okay. Centimeters cubed kills off these, and milliliter. Whew. Can I try the shortcut on top? How about this? I have a 1,000 right here, don't I? Can I cancel one of these 1,000s with one of these 1,000s? Is that okay with you? Everything else down there is a 1 now, so I'm not real concerned about it. This is 10 to the 3. This is 10 to the 3. This is 10 to the 3. Oh, no, 2. 10 to the 2, 10 to the 2. And that's all I have there? So when I put that together with this, I get 3.73 times 10 to the 8, and then add all those up. What is it? 23? Do y'all agree with that? Yeah, that doesn't. Right? This is 6. You're adding exponents. 6, 6, 8, 10, 12. You're adding 12 to 8. 20? Yeah. Did you cancel this 1,000? 10 to the 20 what? Liters. You're going to be out there for a while. That's a lot of liters. That's a lot of water to drink, huh? All right. So I think in terms of the word problems, that's it. You should be able to at least get going on your conversions. Happy with that? All right. Did y'all like a 10-minute break last time? Or do y'all, yeah? Okay. We'll do a little break here. I have 1:45. We'll be back at 1:55. Yeah, I told everyone on these 3 tables that I was going to come by and give you a quiz grade today, right? So I'm going to do that. I'll do it right now. I'll leave that up there for now. You're good. May I borrow your pen? Sure? Thank you. Okay. Juliana. Get you on here. There you are. Okay. So everything going okay for you? No issues? Everything is organized? Very good. Just remember the solutions are online. No guarantees, but... All right, Alex, we talked last time, so you keeping up?
Yeah.
And going okay? Where are you, Alex?
Like all the homework from the beginning?
I just want to see that you've been putting effort in on it. You know, I mean, I'm not going to check and say, you're missing one. So is it Alexis?
Yeah.
Okay. Sure.
I would go by Alex because they were close.
Yeah, I had another Alexis, a guy in my class last semester. I had him for 2 different classes. It's actually a little more common than you would think.
Yeah.
So, all right. So stay on top of it, and if you have questions, contact me. Let me take care of Caesar here. Caesar, how are you doing with your homework, sir? Are you keeping it all in one place? Kind of. Good. All right. So what do y'all think? What do you think your issues are going to be on the test? Any concerns? Panic attacks or?
Right now, mine is the calculator. I'll get one by this weekend.
Okay. Make sure you use it a few times before you come into the test. I've had people like unpacking their calculator, like taking it out of the wrapper, you know, like right before the test, and they don't know how to use the keys. Just make sure you're comfortable with it. Okay. Yeah, you panicking, you think you'll be comfortable?
It's gonna
What?
cover
I don't know,
everything.
like,
I don't know.
I'm not good with tests. Sometimes.
Yeah.
It'll get in my face and I'll forget everything.
You'll freak out.
Yeah.
Okay. like I had told you, try and practice at home. Like, put everything away and, look off these problems. Just like work through. Just pick like 2 or 3 out of each homework section. Just try them. Just kind of randomly. Yeah. Okay. Yes.
I'm just having trouble on this stuff.
The conversions.
You know, some fun.
Okay. No issues? You're good? Okay. You don't have bad test anxiety?
I was an academic decathlon in high school.
Okay. So you're good. You can deal with the pressure? Yeah. So is that like speed stuff where you'd have to like answer
No,
real
it's
quick?
Study and study and study and take some tests for fun because we're idiots. And
Like written tests?
written test, math test,
Okay.
multiple choice.
Okay. So what kind of math did you do in high school? Like where'd you stop at then?
Well, class-wise, I took college algebra,
Yeah.
but for ACTEC, it was some other
Yeah.
stuff. I don't
Yeah.
remember. I just know that it was not anything we were doing in any of my classes.
Yeah. What is your major?
Digital media.
Okay. So you don't need the rigorous math. That's good for you then. You just get through it, right?
Yes.
All right, Aspen.
Yeah.
How's it going for you?
Got it.
Good? Any issues with it?
No.
Do you feel like weaknesses? Like, man, my arithmetic.
Probably just equations, like to remember which equation goes with what.
Okay. All right. Okay. So, are you doing your work on there? You got to be careful with that.
Well, for these I did.
Okay.
Like the smaller ones, but like
Okay.
the last ones that we did, like all of them.
Yeah. Okay. Good.
But for
Good.
these, they were like.
That's fine. That's okay with me. See, Amber, how are you doing? We were talking about you last time.
Bad or good?
No, we were just wondering. I remembered your name, but then you weren't here. I was like, and where's?
No.
Okay. So how's it going with you, homework-wise?
I'm doing good.
Yes. Where are you doing it? I'm coming by to. Oh yeah. Last time I came by and checked everyone's homework for a quiz grade.
Oh, okay. I was like.
So yeah, I'm not just coming by to chit chat. Yeah. So I'm looking just to see where you're doing your homework, just to give you credit for the effort you're putting in.
In this one, I'm just writing this because I have to go back to your videos and find that
That's-
from yesterday.
That's fine. That's fine. So good, nice, neat writing. Do you have any problems with the arithmetic stuff, order of operations or anything? No, you're okay. Okay, that's all. Just keep the work up. Don't fall behind. That's the main thing. And let me make sure I got you here. And who's here? I think I'm missing Carlos. I'll check with him later.
Our homework for like today is gonna be this, right?
You will do all of that. Let me see, and all of that. Yeah, it's a lot of work.
right?
Yes, it's a lot of work.
So we're doing the homework ones and not like the practice.
Yeah, this is what I'm going off of in class. I'm going off the practice. You're going off the homework.
Like all of the practice.
All of it,
and
everything?
homework, and I was like, oh, maybe he just means that.
No, no.
Okay.
Sorry about that. I did mention that in class.
Yeah, but I already did it when you mentioned
Okay.
it.
All right, so let's see. Over here, Lena, how are things going for you? Good? Where are you here? Carolyn, that's why. Okay. All right. Oh, and you'll write in pencil on the test probably? Okay, yeah. Good. That's okay. So you running into any issues? Like keeping up with it, like time-wise and stuff? You're all right?
Not really.
Okay.
I just like after class, we'll just like go to gyms and like sit down and do it.
Okay, good. All right. Okay, you're good. Rebecca. Let's see here. How's it going for you, Rebecca? You nervous about test or you feel good?
Okay, like there's some problems I get stuck on, but
Yeah.
like I get mostly like all the stuff we have learned.
Okay.
It's like such a like the harder problems.
Yeah. So you're just doing them in there?
Yeah.
Attaching them. That's perfect. Okay. Very good. That's all I want to see. All right, I'm not checking you. I got you last time, right? So, but you can take this, start signing it.
Can we put simple stuff like that on there? You didn't say we couldn't. When you handed it to us, you didn't say you can't, right?
I didn't say you could either. No. Here's why. No. Here, I'll give you a new one. Listen. Look, here's, yeah, I should probably mention this. I'll mention it when the class starts back again. Here's 2 fresh ones.
Okay. Do you want those?
So I'm not allowed to write like decimal to the left if I go up.
Maybe I'll let you do that, but I have to tell everyone the same thing. Okay, so hold on.
Oh, you're a teacher.
All right. Do you have a question? Yeah.
The conversions, I gotta count them.
Here, let me take that real quick. Hold on, let me take this.
I know that's gonna be what's gonna really
Get you, okay,
It got me last time too.
okay.
It's the middle part that I really have struggled with, like what to convert first and stuff. So,
I always like I was doing up there, I always like to write what the conversions I'm going to use on the side first, and then go in and fill in the fractions, instead of trying to do it all at one time.
will it always be like? It always be or will it be flipped? Like, would it always be like one
You want
over-
this to go away, right? So the meters has to be down here.
Okay.
That's the whole idea, is that if this was down here, you'd want the 1,000 on top and the 1 km on the bottom.
Okay.
So it's the position of where you start with the original problem that dictates everything after that.
Okay.
Yeah?
So if the meters was down here, then I would put everything on top.
You would flip that 1,000 on top, meters, and put the 1 kilometer on the bottom.
Okay.
Yeah. Okay, I think it's time. Let's see. Bianca and Carlos and John Paul. I need to check y'all off, but we'll do that maybe right towards the end. Is that all right? Pardon me? 2 minutes? That's 1:54? Okay, well, we have 1 minute. You have 1 minute. Get that last little thing in there. What do y'all think of this Pokemon Go thing? Does anybody like it? I don't know.
I think it's pretty fun.
Does anyone like it? You like it? So, shit, man, I start talking about Pokemon Go, and look at this. Everyone's like ready to, we're all having fun now. Wow. Yes. I'm gonna pass that around. Give me a second.
Roaming the world with no guide.
Okay, is everyone ready to continue? Sounds to me like you all want to go outside and look for Pokemons or something.
Do you play?
I know very little about that. Okay, I'm gonna pass the sign-in sheet. All right, everyone. I did not realize that was gonna open.
It's a huge fad.
Everyone ready? Aspen, you ready? You're out of time, Aspen. Wow. You all like Pokemon. That's pretty cool. I don't know much about it, but here's what I will say, and I only have the right to talk because this is my class, so I can talk about it. I think it's kind of weird. To me, it's kind of neat, like a cool idea, but it's also very scary because what I can see is that as this adapts into different things other than chasing little Pokemons around, is that you're actually now integrating the technology into the real world, like, location-wise. And so what you're going to see is more people walking around totally embedded in whatever it is they're doing electronically, paying no attention to what's going on around them, immersed in some other world, as if we're not already bad enough, right? It's bad enough that I give you a 10-minute break, nobody talks to each other at all, everyone's just on their phones. I mean, I'm not saying you, I'm not picking on you, but I mean, we are just so immersed in our own little worlds already in our phones. Just imagine if, you're walking around, you see some person that's like got some headset on and they're like, who knows what they're doing, right? Who knows what their virtual world is, right? They could be looking for more than Pokemons, It can be a lot of different things, right? We're just headed in some really, really scary places. But then at the same time, I mean, what if you could walk in, to these like museums, or you go to the Grand Canyon, and you've got all this interaction that you never could have had before. You go to a World War II memorial and bring up video of a battle. I mean, there's a lot of things that could be used that could be really cool. A totally different experience. But I'm more worried about the guy who's going to like run over the kids down the street because he's doing something while he should be driving. But okay. Anyways. All right. We are going to move on. I guess I'm not going to write on the board with your pen. Thank you. We're going to change gears completely now. This will be the last topic on our exam. All right? We may not finish it today. We may have to pick up some of it on Monday. But I think for the most part, lines are something that we are familiar with. All right? So when we talk about lines, we have to all first agree upon a few things and make sure we're all kind of at the same base point here. When we deal with lines, we're talking about a flat sheet of paper, right? Which we call two-dimensional. This is a two-dimensional surface. It actually has a name. It's called the Cartesian plane. But for us, we'll just say it's this axis. It's this cross that we draw, and we call this thing the x-axis, and we call this the y-axis. This all sound familiar to you? Then if I draw some line on this plane, that line actually represents an infinite number of points. So I have a point here, a point here, a point here, and every point in between, right? That connects together to create this straight line. Every single one of these points, I can get to it by starting at this place right here, which we call the origin. Okay, so this is called the x-axis. This is called the y-axis. This is called the origin. And to get to, let's say, this point right here, I could just walk straight out there, couldn't I? But to make it so that we all have a systematic way of getting to that point, we give this point a set of what we call coordinates, and we write them x, y. And what the x represents is how far we would walk out parallel to the x-axis, and then the y represents how far we would walk out parallel to the y-axis. If the x number here is positive, we move to the right. If it's negative, we move to the left. If the y is positive, we go up. If the y is negative, we move down. Are we all comfortable with that? Yes? Okay, this is called an ordered pair. It's a pair of numbers, right? It's a pair of numbers. And the order matters, right? If I write 2, 3, that's different than 3, 2. So order matters, so we call it an ordered pair. All right, that's the basic layout of a line on a sheet of paper. Now, because lines are straight, if somebody gives us 2 points on a line, then there is a way to get from one point to the other. Do you agree with that? I can go up a certain amount and over a certain amount to get to that point. Or I could have gone over and up to get to that point. So I'm talking about going from one point to another, not the origin to the point, but from one point to another. And for lines, that's always going to be the same up and over for any 2 points. Same ratio. So if I want to go from, let's say, this point to this point, how much I go up by and over by is not the same amount, okay? But it's proportional to it. So if to go from here to here, I went, let's say, up 2 and over 2, then if I take that ratio, 2, 2, if I take this divided by this, 2 over 2 would be 1, then whatever I go up by and over here, if you divide, you should also get 1. So they are proportional. And because that's always the same on all lines, we have a very special number for that proportion, which we call the slope of the line. So the slope is just some representation of the pitch of the line. That all still sound familiar to you? Okay, so the slope, by the definition, the slope of a line is the rise that's in the y direction, right? Rises up and down, divided by what we call the run, which is the left and right or x direction. That's the definition of the slope of a line. It's how much you go up divided by how much you go over. Whatever that is should be the same for any 2 points on this line. Now I'm going to erase this and draw kind of another blank slate here. So if we have our xy axes and somebody gives me 2 points, then there is only one line through those 2 points, right? If somebody gives me 1 point, there's an infinite number of lines that goes through that point. Somebody gives me 2 points, we've locked it in. There's only one line, right? So you have to have 2 points to define a line. And because you need 2 points, we should be able to get the slope if we know just 2 points. And there's a formula for it, so that's what I'm about to give us. Let's first label these. This can be any point. So I could call it xy, right? I could call it AB. I could call it anything I want. I'm going to call this one, let's call this one down here x1, comma y1, and this one x2, y2. We use a little subscript. We're saying, you know, this is the x-coordinate of the first point, the y-coordinate of the first point. This is the x-coordinate of the second point, the y-coordinate of the second point. Then if you have this, the slope is defined to be the rise over run, which we actually use a letter for. Does anyone know the letter that represents the slope of a line? M. M. We use that. That's just standard protocol. Anytime we're working with lines, when someone says M, they're talking about this ratio. And for us, it will be y2 minus y1 over x2 minus x1. That's the formula for the slope. And that reminds me, I was asked about the test on Tuesday, whether or not you're allowed to write anything else down on these, like your own little helpful hints or whatever it is. And the answer is no, all right? And the reason is because everybody needs to have a fair chance at the test, and you know, I don't want someone to have something that someone else doesn't have. We should all have an equal shot at this, if that makes sense. Yeah, I know you don't like that, but you would hate to take a test and then find out that the person next to you had, you know, had put all this stuff on that sheet, because of course, if you would have known that, you would have done that too, right? So I'm making it clear that whatever I hand out to you, you're not allowed to edit or alter in any way. Now, what I may do, and we'll talk about this for sure on Monday, is I have let people use a cheat sheet before, where you create your own kind of formula sheet, where you can write things down. You can write steps and hints and reminders. You can't work any problems out. That sound good? But, because there's always a but, right? But using that is an automatic 5-point penalty on the test. So the highest grade you can get is a 95. That's the type of thing I'm willing to do. If you don't use one, then you can get a perfect score. And for some people, they're like, look, I'll take the 5-point hit just to have that security of something. So that'll be up to you, and we'll talk about that more on Monday. Okay. So that's it. That's the definition. So all you're going to do is you're going to take the number here and subtract this number, then divide it by this number minus this number. So let's find a slope. Here's an example. Find the slope of the line through 2 points. Here they are. 2/3, 5/6, and 5/3, -7/6. I'm just kind of throwing you right into the fire. I'm giving you fractions to start. So you're just going to use the formula that I just presented to you, right? But if you're going to use the formula I just presented, you need to determine which of these is the x1, y1, which one of them is the x2, y2. So I could, if I want, write x1, y1 here, just to kind of let me know that's what I'm going to use, x2, y2 here, and go to the formula, right? But then someone else might want to be a rebel here, right, and be like, you know what, I'm going to call this x2, y2, and this one x1, y1, just because I don't like to follow the herd. And so is it going to matter? Does it matter with slope? Does it matter if I choose this one as my first point, that one as my second, or the other way around? It doesn't matter. We will get the same slope either way. That's good news, right? That you don't have to do it a certain way. So let's try it. Let's use the blue ones, all right? Let's see what we would get. The slope would be equal to, and now I'm just going to use these name things to just call people out. That's fun, right? Mom, I'll let you start. You shouldn't have put mom. It's too easy. All right, Mom. So I'm going to set this up, right? Just tell me what I'm going to write on the top and the bottom here.
-7/6,
Take away 5/6. Good. And you keep going.
5/3.
We all agree? Okay, so now we have to go through and kind of do like an order of operations. This is a big division bar, so we got to figure out what this is first, then divide this, right? So we'll move along to Bethany because you look like you want to answer. You're like, it's like coming out of it. Yes? Okay. So you want to put these together for me? Tell me what that would be. Okay, 6 on the bottom and what on the top? 12. Close. Negative. Good. So you're doing -7, take away 5, -12 over 6. And then on the bottom, I'll move on to Caesar. What's up? What's this? 3/3. Those actually clean up, don't they? I mean, I can actually simplify those now. So this becomes -2 over 1, which is just -2. So our slope's -2. But John Paul did the red one because he doesn't like to follow everyone. He wants to be different. Right, John Paul?
Sure.
Okay, so when John Paul does his, he does
5/6 minus
-7/6. So we've got to be careful there with the minus negative, right? Over
5/3 minus.
other one. We're doing.
Sorry. That's me. Sorry, it threw me there.
No, I know.
2/3 minus 5/3.
2/3 minus 5/3. Right, so that's what John Paul does. And everyone's like, he's going to get it wrong. But he shouldn't. So what happens there when you do 5 take away a negative? is the same as addition, right? Subtracting a negative, two negatives make it a positive, so you get 5 plus 7 is 12 over 6, and then 2 take away 5, negative 3 thirds. The top is a what? 2. The bottom is negative 1. And didn't we talk about this earlier? That the negative, it doesn't matter if it's on the top or the bottom. So I can move it to the top, negative 2 over 1, and then that's exactly this. So we're in good shape, either way. Questions? All right, so now, yes.
Sorry.
No.
So will you take off points if we don't simplify the negative 12 over 6 on the test? Like we don't turn it into 2 over 1 and then negative 2?
Like if you just would have like
If we just left it negative 12 over 6?
like this whole thing just like this. If the fraction can be reduced, I'd like to see it reduced. For something like this, I would want to see negative 2. But if it was something where it was harder to do the reducing mentally, there's some numbers that you just didn't see it, I may be a little less critical of it. But again, it's not wrong, right? It's not wrong. So, I mean, I don't think I would hurt your grade too bad at all. Yeah, it'd be relative. It'd be relatively mild pain. All right, so now let's get to talking about equations of lines. So I told you just a second ago that a line represents an infinite number of points, right? That's what it is. A line is really an infinite number of points. All these points, all these points, all these points, all these points. Each one of them is some x and y coordinate, x and y coordinate. So there's some relationship between the x's and the y's, right? There's some sort of connection. They're all related to each other. And if I draw a different line, all the points that live on this line have a relationship also to each other, but it's different than the relationship on the blue line. And the easiest way to show what that relationship is with an equation. We actually just explicitly write out what the relationship is. So here's one way I could write it. How about if I say, I want you to draw a line where all these x's and y's, every single one of them, all of them, have this relationship. That y is always double the x. Y is always twice the value of the x. Then let's try and draw this line. This is the equation of the line I've just given you. This is the relationship. So give me some points that would live on that line. Give me an x and a y that would satisfy this equation. And think of it as an ordered pair. Give me some x value, some y value that would still make this equation true. Say it again? I heard a bunch of different things. I heard 2 and 1, that's all I heard. 2 and 1? So if I put 2 for x, I'm going to get 1 for y?
If you do 2 and x, you do 4 for
Okay, so if I put 1 for x, I should get 2 for y. So if I plug in 1 for x, then that means the y would have to be 2. What if I plugged in 2 for x? What would the y have to be? 4. If I plug in 3 for x, it's got to be 6. And so all of these points, all of them listed out, draw a line. What about this one? 0, 0, right? Because if I plug in 0 right here for x, it's going to be 2 times 0, which is 0. That means y is 0. Now if I start drawing these, here's 0, 0. 1, 2 means to the right 1, up 2. 2, 4 means 2, and then up 4. So out 2, up 4. We all good? And if I connect them together, I missed one, then I have a straight line. We could change the equation a little bit. If we change the equation, it should change the line, shouldn't it? So let's try this. Let's try y equals negative 2x. What would the difference there be? It would be other side. How do you mean other side?
Going downward.
It's going to go downward? Yeah, give me some values that would work here. So let's just try to, what would happen if you plug in 1 for x? You get negative 2 for y, right? If you plug in 2 for x, you get negative 4. If I plug in 3 for x, get negative 6. What about if I plug in 0? Still get 0, right? Or do you get negative 0? Negative 0 is 0. 0 is not positive or negative. It's neither. All right, so I would still have this point. I would go to the right 1 and down 2. Right 2 down, what, 4? Understand? So when I draw it, I have this. Totally different lines, right? They do share one point in common though, right? They both go through the origin. What would happen if, and I don't want to go through and go into a lot of detail on this one, but what if I change this to y equals 3x? Then this would be 1, 3, 2, 6, 3, 9. And if I started to draw that one, it would actually look like this. It would be a little steeper than this one would be. And what if I put 10x? It would be even steeper and steeper. Now, if I keep on putting bigger numbers for x here, is it going to go and go over this way? No, it just gets steeper and steeper and tries to become vertical, right? If you put negative numbers in there, that's when it goes down this way. Okay, so positives in front, negatives in front. Still something you've seen before? Yes? Okay, good. One more. Let's draw one more, and then we'll get to the nitty-gritty here. Y equals 4x minus 3. That's another equation that I am telling you what the relationship is between x and y. So could you start giving me some points here? How many do I need to draw a line? I only need 2, right? That's all I need. So plug in 2 values, and you get the freedom of plugging in whatever you want for x here. Anyone? 1, 1. Everyone agree that lives on that line? Okay. Give me another one. 2, 5. Everyone agree with that? Yes? I'll do one more even though we don't need it. How about 0? 0, negative 3, right? So if I were to actually plot these, 1, 1 would be roughly somewhere here, 2, 5 would be somewhere over here, and then 0, negative 3 would be somewhere around there, and draw a straight line, and that's it right there. Is that okay? What would happen if I change this number to a 7? would the line become steeper or flatten out? It should become steeper. What point, though, on this, what point would stay the same? 0, 0, -3, right? So think about this. This is important. If I plug 0 in here for x, it kills this off completely, and I'm going to get -3. And that 4 and the 7 didn't have any impact on that, did it? So if I change this to -10, that point's still going to be there, right? If I change that to, 1/2, a fraction, that's still going to be a point. Now, so think of it, it would be all the points that go through that, all the lines that go through that point, right? So this number out here by itself is an important number in the equation of a line. It actually tells you where you're always going to be on this y-axis. And that's why this number is always the y-intercept is what we call it. And this number right here dictates the pitch of the line, which we call the slope. And with that idea, we can introduce what's called the slope-intercept form of a line. The slope-intercept form of a line. And here it is. If this is all familiar to you, then you probably will see this and say, oh yeah, I remember seeing that before. Y equals mx plus b. So if you're ever asked on a test to write the equation of a line in slope-intercept form, they want it to look like this. Now, m in this is the slope, which we've already determined we can calculate that, right? And b is always going to be your y-intercept. Now, when I say y-intercept, what do I mean by y-intercept? It's where the line will cross through the y-axis. That number will always tell me where my line's going to go through the y-axis. Now, do you remember the first problem I did? What was the y-intercept of this one? What was the y-intercept? 0, right? Because remember it went through the origin? Do you remember that? And that means it goes through a y value of 0. And you can see here it's hiding from you, but there's a plus 0 there, isn't there? So anytime there's not a number next to the x term, then you know your line's going to go through the origin. All right, so that's your slope-intercept of a line. Let me give you a problem so this is an example here. Find the slope-intercept. I'm just going to write slope-int form of this line. And we should briefly discuss this. How do I know that that's the equation of a line? Okay, you have an equation, right? You have what else? X and y, right? Anytime you see an equation with x and y in it, it could be a line. There's something else that forces it to be a line. And that's the fact that the power on each of those variables is 1. If you square the x, it's no longer a line, it's a parabola. If you cube it, it's a cubic function. So things change. But as long as these are both 1s, you've got a line. So I want you to write this in slope-intercept form. That means you need to make it look like this, which in layman's terms means solve for y. Isolate y by itself on one side of the equation. So can you get this y by itself? How? You're going to take this 1/2 x and you're going to move it to the other side, which means you're going to subtract it on both sides. Would you like me to write it vertically or just go ahead and do the subtraction? You want to write it? Okay, I'll write it. All right, so I'm going to do minus 1/2 x here. And whatever I do there, I must do here. It's going to cancel on this side. And notice that over here I offset it a little bit because I cannot take negative 1/2 x away from 10 because they're not like terms, right? You have to have the same variables to the same power to be able to combine these. So all that's happened is that it's been moved from the left side to the right side, but it changed signs when it came over to the right. So what do I still have? What's the equation I still have? Negative 2/3 y, 10 minus 1/2 x. Okay, good. Have you solved for y? Almost, right? You have a number in front of it being multiplied, negative 2/3. You don't want that there. You want it to be a 1. So how do you turn negative 2/3 into 1? You multiply it or divide it. You can look at multiplication and division the same way. So let's start with multiply. If you were to multiply, you multiply by what? The reciprocal, right? So you'd multiply by negative 3 over 2. I have to multiply by negative because negative times negative will be positive. And whatever I do on that side, I must do on this side also. This has the effect of, I mean, there's so many different ways you can look at this. You could say negative 3 times negative 2 is 6 over 6, and 6 over 6 is 1. Or you could cancel out the 3's, cancel out the 2's, and do negative 1 times negative 1. Either way, I mean, there's various approaches. This should all turn into a 1, which is what we wanted. So y equals, and then on this side, what did I not put here intentionally to see if you were going to mess up? What do I need? How many terms do I have here? 2 terms, right? And I'm multiplying this side by that. This has to be in parentheses so that you can distribute through. Don't forget that step. What happens when you multiply 10 times negative 3/2? 10 times negative 3/2. That's 10 over 1, right? So that's negative 30 over 2, which is negative 15. Yeah? I'm going to address that in a second. I'm going to do that next, okay? Because that was another option, but I went with the multiplication first. How about this times this? You have to do the fractions, don't you? You have to do negative 3/2 times negative 1/2. And then the x is just going to come along for the ride. So what is it? 3/4, positive or negative? Positive. I have solved for y, right? Is this in slope-intercept form? Does it look like y equals mx plus b? Yeah, but we could probably rearrange it, couldn't we? And write it like this. Y equals mx plus b. What's b here? Yes, what is it? What's the value of b? Negative 15. What's the slope here? 3/4. That's your y-intercept. That's the slope of the line. Be careful on slope. The slope is the number in front of x. You do not put you do not put 3/4 x. It's just 3/4. Okay, so one other option, we're done, but one other option was when we were at this point, Kathleen, right, said let's multiply by the reciprocal. Is that right, Kathleen? Okay, and then who said divide? So if you divide, what would you want to divide by? Negative 2/3. So you would have to divide this side by negative 2/3, and then you would have to divide the entire side over here by negative 2/3, right? We know that this would become a 1 because it's gone. But here, how would you do this? I mean, it depends on you. But remember that division is the same as multiplication of the reciprocal. So you would take this, you would turn this into a times instead of divide, and you would flip that, wouldn't you? And it would be negative 3/2 that you're multiplying. But because it's two terms, you need to do that, and then you wind up exactly back doing it. So we are going to get the same answer either way. I think when you, like if this number out here, like let's just say this number out here was 4, I would divide by 4. But if it's ever a fraction, I always come in with the reciprocal. So on your homework for this, and we're not done, I still have just a few more minutes. For your homework on just looking at the lines section, I'm gonna ask you to do parts A and B for the lines section. And there's problems where they give you an equation, they say write it in slope-intercept form, and then they say find the x-intercept. And we have not talked about the x-intercept. So if I have a line, did I pass the sign in around?
Yes.
Yes? Okay. The tables that I came by and checked your work, you do not have to sign in. If I have a line, it's going to hit the y-axis somewhere, right? And it's also going to hit the x-axis. The y-axis was, the y-intercept was b, wasn't it? But how do we find this thing called the x-intercept? There's a standard way to do it. To find the x-intercept, set y equal to 0 and solve for x. So for example, the problem that I just gave you, right? The problem I just gave you. What was the original problem? What was it 1/2 x?
1/2 x minus 2/3 y.
2/3 y equals 10, like that. That was the problem, right? So on your homework, I'll say put this in slope-intercept form, which is what we did previously. But then I also want you to find the x-intercept. And to do that, you start back at this. All you do is set y equal to 0. So replace that y with 0. What would happen if I replace that y with 0? 2/3 times 0 equals 10. It would kill all that off, wouldn't it? I'd be left with 1/2 x equals 10. And now you're solving for x. It's a linear equation, one variable. What do you think here? Do what? Multiply both sides by 2, and that will kill off the 1/2, won't it? So 2 times 1/2 equals 2 times 10, so x is 20. That's your x-intercept. Now we want to write it as a point though, all right? So if you're sitting here, right, on the x-axis, and I want to write that as a point, I'm telling you that the x-coordinate must be 20, right? What's the y-coordinate? 0, because remember, that's how we got to it, right? And anytime, right, anytime you're on the y-axis, agree? If I'm anywhere on the y-axis, I said y-axis. Anytime I am on the x-axis, right, my y-coordinate must be 0. Okay. All right. So I'm going to just talk briefly about the next section. I'm not going to get in any problems. You can start packing up. Is everyone clear on the homework? You're supposed to finish up all the conversion homework, okay? But from the line section for homework,